Okay, now we have completed the first section and we are on to our next section, linear equations in two variables. And the first theme we will cover in this section is solutions to linear equations in two variables. So let's get started. Here is our first slide here, which is actually a recap of the basic concept here. So we have this two variable linear equation 2x plus y equal to 3, and we have to find solutions corresponding to these x values. So we are given four x values and we have to calculate the corresponding y values and complete these four solutions. So let's do that. So the first x value is -1. So if I substitute -1 over here, I'll get -2 plus y equal to 3 or y equal to 5. So -1, 5 will be one possible solution for this equation. If I put x equal to 0 over here, I'll get 0 plus y equal to 3 or y is equal to 3. So 0, 3 is another solution. If I substitute x equal to 1, I'll get 2 plus y equal to 3 or y will come out to be 1. So 1, 1 is another possible solution. And then if I substitute x equal to 2, I'll get 4 plus y equal to 3 or y equal to -1. So -1, 2, -1 will be one more possible solution of this two variable linear equation. Now let's plot all of these solutions on this graph over here. So the first solution is -1, 5, which is this point over here. Then you have 0, 3, which is this point over here. Then you have 1, 1, which is this point over here. And then you have 2, -1. So that's this point over here. And if you notice carefully, all of these 4 points actually lie on a straight line. And let me actually just draw that straight line quickly. And so that's the thing. All of these 4 solutions lie on this straight line. And by the way, if you pick up any other point on this line, the coordinates, the x and y coordinates of that point will also be a solution of this equation. So if you plot all possible solutions of this equation, you will get a straight line in the plane. And that's the key idea here. For any two variable linear equation, the number of solutions is infinitely many, and those solutions form a straight line. Now here's a problem for us to solve an SAT sampler. If 8, -3 lies on the graph of the equation px plus 2y minus 10 equal to 0. So this is a two variable linear equation whose graph will be a straight line, and 8, -3 lies on that straight line. Then find the value of p. So it's a very straightforward problem. All we need to do is observe that because 8, -3 is a solution of this equation or lies on the graph of this line of this equation, the coordinates 8 and -3 will satisfy this equation. So we can simply plug in those values into this equation and find the value of p. So the equation is px plus 2y minus 10 equal to 0. So instead of x, we'll plug in 8, and instead of y, we will plug in -3, and this should be true. So p times 8 plus 2 times -3 minus 10 is equal to 0. So 8p, and then I get -6 minus 6, and then I get -10 equal to 0. If I combine these two terms, I get -16. So 8p minus 16 is equal to 0, which means that 8p is equal to 16. And now I can divide both sides by 8, and that will give me p is equal to 2. Okay, so for if that point 8, -3 lies on this line, it must mean that p is equal to 2. So that's our answer to this problem. Now here's our next problem. If the point m, n lies on the graph of this equation 5x plus my minus 3 equal to 0, where m and n are constants, find the value of m. So once again, we are given this point that lies on the graph of this equation or satisfies this equation. It means that the coordinates m and n will satisfy this equation. So if for x we plug in m and for y we plug in n, which are the coordinates of that point, this equality should hold true. So let's do that. So I get 5 times m plus m times n minus 3 is equal to 0. So remember we have to find the value of m, so let's try and isolate that. So we have 5m plus mn minus 3 is equal to 0, so I can write this as is equal to 3, and I have this positive 3 on the right side. And now I can see that I have these m's common here, so I can write the left side as m times 5 plus n is equal to 3. And now I divide both sides by 5 plus n to isolate m, and that will give me m is equal to 3 over 5 plus n. Okay, so this should be our answer, and let's see, 3 over 5 plus n is option A, so that's the correct answer. Now we come to our next theme, modeling real world situations using linear equations in two variables, and here is our first SAT sampler on this theme. A store sells two types of nuts, almonds which cost $1 per ounce and cashews which cost $3 per ounce. A customer wants to buy a mixture of nuts that costs $70. If X and Y represent the number of ounces of almonds and cashews respectively, which equation represents this situation? So seems like there's a lot of text, lots of words, but the situation is actually really simple. Almonds cost $1 per ounce and there are X ounces of almonds. So the total cost of the almonds would be X into X times $1. And you have cashews costing $3 per ounce and you have Y ounces of cashews. So the total cost of the cashews would be Y times $3. And this should sum up to the total cost, which is given as $70. So this total should come out to $70. So let's just write it as a two variable linear equation. So X times 1 is just X, and then we have Y times 3, which is just 3Y. So X plus 3Y should be equal to this total amount, which is 70. So that's it. This is the two variable linear equation modeling this situation, and this is in option D. So that's the correct answer.